All right. So, what are we up to? I have looked at this stuff. What have I done? I have been going through my DFA construction file. I did like 2 bits of testing, and now I'm like pretty sure that it's like 20% correct, and I think that's good enough. So there were some minor debugging issues, like some minor things I forgot to do that I commented. Uh, like, for example, I forgot to initialize the DFA node edges array when I create a DFA node. So that was pretty funny. I also forgot to I forgot to actually use the Zobrist hash table. Like, I forgot to add DFA nodes, or at least the sets associated with those nodes, to the Zobrist. So that whole thing wasn't even being used correctly. So I had to do that. Anything else of note? Oh yeah, in the when doing my moving stuff and looping through, all my different characters that we should be looking for, I would, try to apply the move function to get the new nodes. That could be the to get the new nodes. And if that set was empty, I shouldn't try to do anything at that point. That means, there's nothing to do. So I should continue the loop to the next character, to the next character. I forgot to do that, so it was running with an empty set and just trying to do things, which was a bit silly. Um, Anything else of note before I talk about the major thing? No, I don't think so. I think that was the main, like, small things. And the big things were I had to change. I didn't have to, but I made a bunch of things double pointers. So here, this became a double pointer. This became a double pointer. That I think was always a double pointer, but that had to become a double pointer. Uh, that I think also became a double pointer. The reason was because whenever you use add, hash set add, and you pass, a hash set to add something to it, the risk becomes that if it has to be resized, then the hash set, the location of the hash set changes, right, to the new hash set with the bigger capacity. And that's all cool, but when you return back to the sort of parent caller, the parent function that's done all this calling, the way I had written it was such that that new hash, that new location, that new hash set that was being malloc wasn't being communicated back, because like it's like if when this was like this, when there was one pointer, and you passed, the address like this, there was a risk of like, yeah, there's a double pointer which points to the res object. Maybe this one actually is okay, now that I think about it. But if I'll keep this like this. If I go to epsilon closure, this is where I actually found the bug, because there was a test case I was running with. This test case I was running with that was like it was throwing exceptions and stuff, crashing and things with sanitizers. If I had this as a single, for example, visited as a single, ignore their errors for now. When I add, it was written like this. It was an ampersand, right? Because the hash set add takes the address of the pointer. When I do that, the function in here gets a copy of this address and, does all the work. It adds the thing and redirects that copy to the correct new location if required. If the resizing is done, then the copy of this gets pointed correctly. But when I return back to here, or rather back to here, I should say this again. This made no sense. Sorry, one more time. When I create my visited set, right, I have this on the heap and then a pointer pointing to that thing on the heap. This is a pointer on the stack that points to the hash set that is on the heap, right? So I have that. I then pass this. If I pass this as a single pointer, then I get a copy. This is what I'm talking about. I got confused. This is where this guy gets a copy of the visited pointer. So it's pointing to the same thing, but it's a copy of the pointer. So the pointer itself is like a different instance of a pointer. They're pointing to the same thing, but it's a different instance, right? Because it's a function call, different stack frame. So when I do all this, it's this pointer that's being edited and being checked and like having all the operations run on it. So if a new hash set gets created because of the resizing operation, it's this pointer which will be redirected to the correct place. But when I return back to here, we have problems because this guy is still pointing to the old hash set. This guy is pointing to the new hash set. This guy is still pointing to the old, which, by the way, the resizing function freeze completely cleans that up. So that thing doesn't even exist anymore, and this dude's still pointing to it. So then I got heap use after free errors because of that. So yeah, I made this a double pointer, and then I got a similar error with this guy. It was also like, oh, if you make this a single, then the NFA nodes, which I created from here, like I think originally this was a single pointer, had the same issue. So I found that it was just, I don't know if clean is the right word, but it was just less of a hassle if everything was kind of double pointers. So anytime hash set add was involved, right? In this case, it's here. And then also in that res thing here, I just thought, just use a double pointer, then, I'm pretty confident that nothing terrible can happen. And yeah, nothing terrible happened, I think. So yeah, I think it's working. So if I do this, I made it so that, what the heck? Okay, whatever. Wait, when did that get printed? I don't remember doing that. Huh, okay, sure. Don't need that anymore. In which case, I can just write this as one line. Sorry, anyway, whoa. Did I mess up? Did I forget to undo stuff? Oh no. Yes, you should be that, shouldn't you? I think I did modify that and forgot to change it back. That should be it. Whoa, why am I doing triple pointers? Yes, you can be like that now, sorry. So now if I run this, then it gives me sort of text regarding where the edges are between what nodes, and then also tells me which nodes are finishing, because you can have more than one. And so I did a lot of drawing. So for this regex, this is the NFA, and the highlighting was part of my debugging. And then this is the DFA based on these instructions. And manually I ran through the algorithm as well, and I found that, yeah, this works. So I'm pretty sure that things work correctly. Something else I should mention is, like, if you have a dot, you get a lot of output. Basically, remember for this regex, for most, I think all regex instances, dot means any character is allowed to be matched. So, the dot should match an A, a B, a C, and whatever, right? So how I treated the dot was, for every symbol, if you see a dot edge, you should draw an edge with that symbol. So like for the symbol A at a particular node, like this is the move, this is the thing about the move operation. If, with the symbol A, with the character A at a particular node, if you see an edge, an outgoing edge, which is labeled with a dot, a period, or a full stop, you should create an edge with the symbol A on the DFA nodes, between the DFA nodes. So for every dot, you basically get 60 edges. One for each symbol. Around 60, I don't know how many exactly, but yeah. This is a space, by the way. The spelling here is a space because the very first character that I look at is a space character. So space character, exclamation mark, double quote, hashtag, etc. All those edges get made between, in this case, 0 to 1, because the NFA, is this connected? Yeah, the NFA would look like this, and the DFA looks very similar, except it has to be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and each of these are labeled with a unique symbol. So, you know, I'm not sure if that's the best way to do things, but it is a way. So yeah, I think today I'll just do some chill stuff because I have like a to-do list I need to do. Of course, one of the main things is structure everything correctly, right? Use include and source instead of one big C file. But before I do that, I need to make sure I have a cleanup off function to actually free all the structures. I want to make an init DFA function because right now when I create my DFA, I think it's like 3 lines, but it's like very ugly. To do this in like the outermost function is like kind of dumb, so I should wrap that in a function. Oh yeah, and then I just realized I kind of like my pass expression function. This is from the other sections. My pass expression takes in the pointer, right? That's how I designed it. But now I've realized from a public view, like I know that this pointer should start at index 0. So the private side should handle like this stuff. The public API or whatever shouldn't need the user, like I shouldn't demand the user to give me a pointer. I should create the pointer. So there should be a public function that the public calls, and then within the internals I will handle the pointer stuff. So, and a similar idea for translate expression. I expect a num nodes counter to be given to me as a pointer, but I shouldn't, like the public shouldn't need to do that. So some minor edits, but those are less priority. First priority is that. Second priority is that. Third priority, we'll structure everything, and then we'll do these later, basically. I'm hoping if I can do things, if I'm not too silly, I'm hoping to try do the matching today as well, because I feel like I've got my DFA. There is another process called minimization. It's like state minimization, where you can make the DFA smaller by like doing certain tricks, but you still get a DFA out. It's still a DFA. It's just a smaller DFA, more efficient. So yeah, you can increase efficiency that way, but I'm not going to do that. I feel like I've changed the way I've named things. Construct DFA. Like in the hash set, I labeled all my functions as like hash set resize, hash set. Oh, maybe I didn't. I feel like wait, let me look at this. Yeah, like hash set add, hash set exists, hash set, which I think I like. Here I've done not that. I don't know what I want to do. In my freeing, wait, when I look at NFA, what did I call the freeing function? NFA free. Okay, so I'll call this DFA free. Okay, that decides that. And then NFA, DFA, sorry. Okay, so let me think about my structures. I have a DFA which has a start node. So I can, assuming I am not wrong, which I may be, but I don't think I am, I should be able to do a DFS, basically, another DFS, in order to find all the nodes. Yeah, so it should be the same way that I free this, right? Except a DFA node has edges and has sets and stuff, so I have to free the sets. But I have a function for that, so that should be fine. Okay, so DFA free is going to need a helper called DFA free DFS, which takes in a source node, takes in the visited, yeah, and takes in doesn't need anything else. I've written like 4 DFSs for this, and I can't for the life of me just memorize anything. Source, you have the DFS, you check if it's visited. If it's not visited, then you look at the neighbors, which can still be accessed by a source, and then yeah, I think that's enough. Okay, so if source ID, nope, I did that wrong. If visited at source ID, then continue. No, return, we're doing recursively. Because recursion is easy to write and stacks are annoying. So yeah, if I visited already, there's no point in doing it again. So return. Otherwise, we can set visited source at ID. What am I doing? To equal true. And then we can be like, oh, for int I equals 0, I should be less than the source edges size plus I. So we're going through all the edges. We're going to look at the current edge. It's called DFA edge. DFA edge is equal to DFA. What am I doing? Source edges data at I. It's one of my dynamic arrays. Get the edge, and then if no DFA edge neighbor DFA free DFS given this neighbor and give it the same visited, right? Traverse into that neighbor, free, you know, anything you can. Then you should free the edge. Is that fair? But you shouldn't free the node because you might. Oh wait, let me look at how I did this because I feel like it'll be similar. Oh, I did BFS. Does it matter? Surely it doesn't make a difference. Wait. So you have your visited thing, fine. You create a queue because it's BFS, fine. You append the queue, fine. You append, like you add the start to the queue, fine. You have a queue pointer, like the queue head. While assessing the queue size, it's normal stuff. Get the current queue out of the, so it's like as if you pop off the stack or you dequeue. Go through the edges. Get the current ID, get the current neighbor. And then because it's BFS, you check visit if it's visited here. If it's not visited, then set it to visited and append it to the queue. I print some stuff, and then you free the edge stuff. Then you free those edges out of the node because you shouldn't ever need them again. Ah, right. Having a queue was nice because I had it ended up being like a list of nodes that I could use at the end. That's what it was. Because I didn't want to, because there was an issue where if I free the node as I visit it, or after I visit it, like over here, there was an issue where if you traverse one way and you free out stuff and you backtrack and you traverse another way, and that other way happens to hit one of the nodes you've seen before, that node has been freed. And you're like, oh no, I freed that node. So when you access this guy and you do this, where, as in when you do this, when you run this line with the neighbor and you do this with that neighbor and that neighbor's been freed already, then this will obliterate itself. Is there a way to check if an address has been freed? Because that would be the other case. Like if the address has been freed or it's been visited. I guess what I could do is do it via integer. No, but then I can't. That doesn't make sense because I don't have access to the resource. Okay, I have an idea, but it's kind of dumb, but I think it will work. I give both int source ID. No, that doesn't make sense. Sorry. Because in order to give the source ID, here I'd have to say DFA edge neighbor ID, which would be the same problem. Like I'd be accessing something that's been freed, so. Do I really have to make a queue or a stack? I guess it would be a queue so that I don't lose stuff, because a stack I would actually be popping things off. Queue, you can kind of get away with like keeping the elements at the front and just like moving the index along. Ah, I really want to do that. Is this how graphs get freed? Like, is that what people do? They only do the edges and then have a list of nodes at the end? What if I... Let me think. I really want to just do what the DFS could have done with. Maybe it's a thing. How to check if a address has been freed at runtime? Yeah. Yup. Use code with caution. Oh, that's because, yeah. I respect that, yeah. Setting it to null. Yeah. Right? That would work. Because it's like... So you do like... Okay, you free the DFA edge. Which means like... freeing not the neighbor. You're just freeing the actual edge, I think. So you go through the edges, then you DFA edges free this guy's edges, source's edges, and after you freed his after you freed that array, so we freed the actual edge objects, and then we free the dynamic array that was holding those edge objects, and then you free... No, this doesn't make any sense. Right? This doesn't make any sense. You free... You... the set, you have to hash set free. Given the sources set, and given that's it. And then you free the source. If I try to set the source to null, that's not gonna do anything. Because I traverse through one way, and as I back up, I go through the edges, I free all that, I back up, I free the edges, I free the set associated with me, I free myself, and I set this to null. When I backtrack again, and if I backtrack, come back around, and I hit that node again, like the edge neighbor is still going to be set to some random address. It's not going to be set to null, alright? Alright, I'll do it as a BFS. Oh, I'll bite the bullet, it's fine. Oh, I have a queue. I probably just assumed I'd need it. Oh no, I did it here. Huh, okay. Well, then I have to do it at that point. I didn't even remember doing this. I have a queue. Hash set, source set, hash set add, epsilon closure. I have a queue? Oh no, yeah, of course I have a queue. I discussed this. I need a queue or a stack in order to... Yeah, okay, I'm stupid, yeah. Okay, good thing I went with the queue because I need that anyway. It's the exact same type as well. It's a bunch of DFA node stars that I need to enqueue. Okay, cool. So... Okay, so we call it DFA free. This is completely useless. Well, it's not useless, but it's useless. I basically just copy this. Let me literally... This is basically the template, I think, as far as I'm aware. Let me get rid of this, and let me just try and see what I can do. So DFA num nodes, and then DFA num nodes, yeah. So I'm going to make an array like that. This should not be called that. This should be called DFA node queue equals DFA node queue init. Yes. DFA start. We're appending that start got the head pointer. I like to call it Q head now. Just feel like it's better. While it's smaller than the Q size, while it's a valid index, we get the current node. This is DFA node now. Oops. Is equal to that. For int I equals 0, I less than this guy. Yep, so going through each edge, we get the neighbor ID. If it's not visited, then enqueue it. Wait, hold up. Oh no, yeah. Ah, right, sorry. The visited is marked as true, and then this gets the edge and the actual neighbor. I feel like it's better just to say, got the queue, bing bong, and then, okay, yeah, I wanted to rename this. I want to get a DFA node. Neighbor is equal to, is that fair game? Because, yeah, okay. And then int neighbor ID is equal to neighbor ID. Oh, I don't need to do that. Neighbor ID. Otherwise give the neighbor. Okay. Then you should free the spelling. I don't have to do that because it's not a pointer. It's a char, so that's not something to free, I think. And free the what? Oh yeah. Oh yeah. Wait, what? Freeing the actual edge. Yes, fair enough. Oh, that makes sense. And then free the dynamic array. Then free my visited. Then for int I equals 0, I less than this, free Q data at I. Yes. Free the Q and then free the DFA. So my understanding is that by following basically what I did here, I should have something relatively identical. Okay. So, can I test this? Print the DFA, free, or DFA, free, given the DFA. Okay, so I think I have to compile this without anything, right? I've just been using shell files, which is maybe dumb, but I'm just trying to avoid having to use CMake. Not because I don't like CMake, just because I can't remember how to use it and I can't be bothered reading the docs for it right now. So gmod. In fact, what if I go, what is it? Leaks? At exit? I think it's like that. I missed. Whoa. Okay, maybe I shouldn't do that. I didn't save. I've made a silly, yeah, fair enough. DFA node Q free. It's the only risk is when you do copying and pasting, you don't actually know what's going on. And then same vibe over here. DFA edges free. Good. Anything else? Exact same things. So you basically just look for node Q and see if there's anything. That was not helpful. Yeah, okay, looks okay. Anything else? Okay, let's just try that. Okay, and then yeah, first things first, let me just run it. Let me just see if I broke anything. Okay, looks okay. I mean, I don't know if it's correct, but and then yeah, call the free. So let me do the leaks thing. Leaks at exit. Cool. Does that confirm that it is correct? Absolutely not. But I mean, it makes sense because it's pretty much the same thing. I just have to free the hash set as well, which I do, right? Wait, no, I don't. Did I do that? Oh, I didn't run it with something. That's why. Yeah, okay, hang on. I forgot to do this because I was following a template. That would have been bad. I almost just let it go. So when you free the node like this, you first want to free the set. That's an integer, that's a boolean, and that's been freed, I think. So set, which means I need to do hash set free, bang, and that should free that properly. Let me try that. I'm dumb. I need to compile it. No, interesting. Okay, there's more to it than that. I can't think of what else would be there. malloc get NFA lookup. Oh, of course. Interesting. So you free the DFA, you also have to free the lookup, which is over somewhere. Do I not do that here? Wait, what? I make it here, so I have to. Ooh, wait. Yeah, that should be fine. So long as I free this, we're working. We're fine. Because basically, I was thinking I might have to free everything inside, but if I run free NFA, which I did not do, there's a bunch of stuff I need to free. Okay, hang on. NFA free. Expression. What was it? Free? Is it free expression? See, that needs to change. It needs to be expression free, or like expression pass, or something, like, you know, it needs to be consistent, and it's not. All right, let's try that. Please don't blow up. Oh, it blew up. Is there a line number? I mean, it's literally this. Construct the. Oh, it's the same thing. I forgot to free this. Fair enough. Free lookup, free the. So what is it called? DFA node Q free. Did I just call it Q because I'm lazy? No, I actually did the full name. It's very surprising. What other? Oh, I got an iterable that I didn't free. That's cool. Zobrist I didn't free. Okay, thank you. Jesus. Oh my god. I thought there would be some, but I didn't think there'd be this many. Hash set. Okay, so there's a get iterable. Where did I call that? Epsilon closure? Oh, I literally just didn't call it at all when I used epsilon closure. Okay, that would explain why there's so many of them. What do I call it? Iterable free? Header? Okay, so there's that guy. I said something about Zobrist as well, right? Where do I do that? When did I create the Zobrist set? Here, in the construct. Okay, so I need to free this over here. Free, what, Zobrist free? Give him the Zobrist set. Okay, so that's done. Do that again. I've already forgotten what else was there. Okay, it's still this big slab. Hash set get iterable. Is there another place where I got an iterable? It didn't work with it properly? Seems to all be. Oh wait. Hash set init. Oh, there's a hash set I'm not freeing as well. Oh, there's so much output that it can't even. That's not good. Calloc in hash set init. Calloc. Oh, is this somewhere else? Did it say calloc? Was I misreading that? Did I just have like a weird. Okay. malloc in hash set get iterable. No line numbers? Am I reading this correctly? Fantastic. Okay, hang on. Hash set get iterable. I'm gonna do it twice. Epsilon closure. I've called the free function here. Move function. Ah, right. Fair enough. Iterable free, given the iter. Whoops. Here, and then free it over here when you're done with it. Compile. Surely that chops it down by half or something. Yeah, okay, at least I can print all of it out. Hash set init. Where else do I do this? The source set? But that would have been linked with the source node, which becomes the DFA start. So I think that would have been handled. I'm fairly sure. So I don't think it's that one. Visited. I do free it here. Oh no, I have no idea then. Wait. Yeah, I have no idea. If it's one of these three, I would have thought that this got freed when I do the BFS thing with the queue and all that. I would have thought this got freed here. 80 bytes. See, there is a calloc, I'm not crazy. But that makes sense because this uses a calloc, does it? Wait, the hash table is... Wait, no, but... Did I not free that correctly? Okay. So this is indicating that something's not being freed. Possibly because of the resizing. Maybe that's not being freed correctly. But I thought I did free that. Hash set... Like a resize... In my resize function, I freed the hash set of the old stuff. I free the old hash set. Hash table. And I free the old hash set. Again, double pointers. I don't know if I had that before, but I have it now. Along with plenty of nesting. Because we love nesting. I'm a bit confused. So the calc indicates that it's the hash table not being freed. And 80 bytes also makes sense, I think, because the hash table consists of some things. What's a hash set again? I mean, what's the hash table consist of? The hash set consists of a hash table, which is a I wouldn't have expected 80 bytes, to be honest. I would have thought like 64 or something. Because like 80 bytes makes it seem like it's 10 times 8 pointers. Sorry, 8 times 10 pointers. Like where each pointer is 8 bytes. And then 112 divided by 8, 14 pointers? Like, I would have thought it was like enough space for 8 pointers and then enough space for 16 pointers, you know, because of the whole doubling thing. That might not make any sense. It doesn't matter. What does matter is that I don't seem to be able to... Oh, wait, no, I'm dumb, sorry. It's 80 bytes and 112 is like the root leak. Because you... That actually makes no sense to me. Huh? Normally I'm not bad at freeing stuff, but I've literally... As in like, when I read this stuff, normally I can get an idea as to where the leak would be, but I'm genuinely bewildered by my lack of foresight. If I compile with -G, will it let me... Will it give me line numbers or at all, or... Because I know was it... Oh, wait, this looks more helpful. malloc in Zobrist add. I have no idea. Did I compile? Wait, what? There's a lot of output in my brain. Okay, yeah, this is where I compiled, and then any line numbers? Oh, wait. Yeah, I think that giving it the -G means it can actually give you line numbers and stuff. Wait a minute, wait a minute. So they're saying that the hash, so when I ran DFA construction, I ran construct DFA over here. From there, I went to move. I called hash set, I did hash set init, yeah, in hash set integer. Hash set init. Sorry, I'm like really tripped out. In the main function, I get the DFA, specifically part of the, it's in the while loop, it's a bit more annoying to follow. Although the input's very small, so it shouldn't be that big a deal. So it's this line, is it 225? Yeah. So in that line, I call the move function, and in the move function, I ask for a hash set init, which is the res, which I return, and so it's that hash set specifically. Oops. When I do this malloc, and it's claiming that that's a problem because it's not being freed. So the hash set is not being freed. And this is the hash set, which is the res. So it's like the DFA node hash set. Create DFA node. I'm wondering, like, so the Zobrist thing has hash sets in it as well, which are like the same DFA. But those weren't copies, those were the same addresses, weren't they? Yeah, like it's an address to the same thing on the heap. So the set is just an address. I think, yeah. Wow, my brain is like not figuring this out at all. Wow, even with the stack calls and stuff, I still can't imagine what it would be. Because my understanding is when I do my BFS thing, and I call hash set free on the set, I thought that would free the hash set. And like all the places where that hash set exists, in the Zobrist, in the DFA node, and anywhere else, I thought it would be freed. But now I'm doubting because I feel like I'm misunderstanding something. Let me look somewhere else. What about here? An instance, so when you did this, that's not good. Shouldn't that be handled by the Zobrist itself? The hash table in Zobrist. Can't tell if I'm like, I swear I didn't have these problems before. Oh wait, this is going to be a bit scary actually. Should I be freeing the entire Zobrist hash set? Because like, okay, now I'm tripping out because now I'm thinking this is actually a problem because when I call Zobrist free on this guy, now I'm trying to think, like, does the Zobrist hash thing does it get rid of all of... I'm worried about use after... I mean, it's not even a problem. Like, I'm worried about use after free errors, but it didn't happen at all, so... When I free this, and I do this, and I return the DFA... I print the DFA... But maybe I just don't access the set ever again. Curious about that. But, okay, I don't think that's the major problem anyway. I don't know if I made any sense in any of that, but it's fine. For now, I just have to think, why is it that despite calling the Zobrist free function, which does seem to do what it's supposed to do, it's saying that at line 109, the mallocing of a Zobrist element wait. I free, what do I free? I free the HT. Which is that guy. No, but I also free this. Ah. Yeah, wait, what? I free the set. Okay, I think I'm seeing what's the problem. I have to actually free the Zobrist element. Don't I? Right? This is wrong. Just that is fine. H and I is a Zobrist element thing. So yeah. Okay. That's fair enough. I didn't fully clock what was happening, but I think that'll at least clean that up a bit. Did that help or? There's nothing about Zobrist anymore, so I think we're good. Now it's just this big ass slab. $37 kilobytes, 374 leaks for about 20 kilobytes, 21 kilobytes of leaked bytes, 21 kilobyte leakage. Okay, hang on. So DFA construction. I construct the DFA I do the move function. I initialize a hash set to create the res. It's line 161. Yeah, I initialize the hash set, so I go in here, which is over on the right side, and it's this guy, line 10. Yeah, do I not free the actual hash set? Is that what I've done? Is that what I've forgotten to do? I'm so confused. Hash set init. I malloc an HS. Just look at this. I malloc the HS, which is all of this stuff. And then I have to I should also free each hash set item. Which is like, I calc all this. So I have to free each item, then free this, then free this. I feel like I did. Okay, so I think I backed the function. I free each item, then I free the table, then I free the overall struct. So I must not be calling... The BFS must not be working correctly. Because I think this is correct. I can't see how that would be wrong. So the res, which stores... The res which gets the address of that particular hash set gets returned from over here. The new nodes pointing to that same thing. Oh. Huh. Free the new nodes and then continue. There you go. Interesting. Alright, I've taken too long. Alright. Had to do a quick cut, but we're fine. Alright, so I've done this, I think. And I want to make an init function. Okay, so yeah, where I do... Where is it? In the main construction. This part. Okay, so DFA star DFA init. I literally just do this. I malloc. I set this to the thing, and I set this to null, and then I return this. So this can be written as DFA init. And hopefully nothing bad happens. Do I have the... Oh, I broke it. Pointer being freed was not allocated. Oh no. But probably wasn't from this, I assume. If my understanding of code is correct, I don't think that's the reason. It's probably from one of the times I... Oh dear. Okay, I was talking about how I thought maybe there might be some problems when you Zobrist free everything. I don't know if that's important at all. Okay, let me compile with the address and then do this again. It's really unfortunate that. So we're freeing a hash set. Inside 16 bytes inside of a 24-byte region. So 0001. I don't know what that means. One of the addresses. It was previously allocated here in the resize. Of course, it's the resize function. Oh man. Heap use after free. Hash set integer 228. I'm trying to get its total size and it causes problems. Interesting. Yeah. So trying to read the 4 bytes, which is the total size, but that's been nulled. I mean, that's been freed already. This has been freed. I'm going to go out on a limb and say, I think it's because of this. When you call the DFA free, oh, it's not. Okay. Oh, I didn't save. Hang on. Wait, one more time. Yeah, it is that. Okay. I was keeping track, and I noted that before. So now I have to think about what to do. Zobrist free. So the issue is I'm freeing the hash set here, but I shouldn't. So I have 2 options, and I think what I would prefer is I would prefer to have Zobrist set here, not do it here, create it out here. Why can't I type? Given the upper bound. Yeah, the NFA size. And then I can pass that into here. But I'm going to have the other problem though. It's going to be the other way around. I'm going to try and... Okay, maybe this is pointless. What I might have to do... So if I compile this and run it, it blows up. If I don't do this and do this, then it doesn't. But of course I'm leaking memory. So I need a Zobrist... Should I have like a full free, why free everything including the sets? Or maybe the Zobrist free should just not be responsible for freeing the hash sets. You know, like Zobrist not... Is that fair? I feel like that's dumb. Maybe I should just make a second free free the like structure but not the actual items. So it's like I just do these 2 lines. I free the HT and I free the ZEP. I don't free the actual sets yet. Where's the... I need this guy. This is sort of dumb, but... Wait, what am I doing? There you go. And if I do this with leaks, I should compile it without the sanitizer when I use leaks. Oh, of course. Well, maybe I'll use the same one. what? Wait, hold on. I didn't test this one before. I only did this one. Oh, it's broken as well. Fantastic. Oh, because this. Right. Because I forgot to do this. The random key table, which is part of the structure. Compile it. Still no. A bit surprised now. Oh crap. If it's malloc, then the Zobrist add. The Zobrist add means it's a set. Which means I don't leak. I guess I'm not. Maybe I'm not freeing the sets correctly. Ugh. So much output. I'm not even reading anything, I'm just like looking at the pretty text. So the start and the main, you got the DFA construction, so you got main, construct, and DFA. Create the DFA node, Zobrist add. So yeah, when you do Zobrist add, you malloc a particular element. Oh wait, you have to free the elements. Okay. So you have to do all this. Okay, it's literally the same function. It's just that maybe, you know what am I doing? I'll just have a boolean that says free the sets, and then be like, if free the sets, then do this, you know, and then always free this. That way I can make, then it's like the user's choice. It's not always fantastic to rely on like boolean stuff, like flags, but I think it's fine. And of course, no errors. I mean, no like error messages, because that would make life too easy. So just free, and I'll say false. Do not free the sets. But everything else should happen. So this just won't run because I've set it to false. Everything else, this will free, this will free, this will free. I once again forgot about actually freeing this guy, which is why the leak is happening. Bang. Okay, and then check with the sanitizer. Nice and simple. To be fair, the sanitizer usually drips out with longer input. Okay, that's good. And then also do the memory leak thing with this input. So compile it with just G, oops, and then leaks. Damn it. You'll see simple. Some iterable. Oh no. Not the resize function again. Oh my goodness. $111 leaks. 111. So the resizing function, main constructs in the move function, epsilon closure DFS, DFS, you DFS 3 times, you hash set add, which triggers a hash set resize. When you malloc the new, So this malloc. So you're telling me this new malloc thing doesn't get freed correctly? Is that what you're telling me? Is that what we're trying to go at? Oh, but this hash set. Wait, this is wrong. This hash set, the HS new, gets pointed to by the incoming hash set double pointer. So I don't lose it, right? And then either it sticks around till the end or it gets freed in the resize itself. Struct DFA. Oh, you're joking. Hash set add. What? Epsilon closure 88. Oops. 83, I mean. You have a for loop. How can it... What? Epsilon closure DFS. DFA construction line 83. Yeah, so from there. Hash set add. Is I meant to say 81 or something? It'd actually be very helpful if I knew which hash set add call was causing it, but it's saying line 83, which just doesn't make any sense. So I keep rerunning it because I'm like, maybe it's just something hasn't saved or something. Not debuggable. Yeah, 83. Okay. Hash set add, specifically the hash set reset. Okay, well it seems to be like off by a line, so chances are it's 80. Well, actually, I don't know if I can say that. So it goes into hash set new hash set. Hash set integer 23. Yeah, so this malloc never got freed, which tells us that my understanding of how this worked is completely wrong. Because I thought this hash set would eventually get associated with a particular, well, either it's the visited, right? In which case that gets freed like by the end. Like if we're adding to the visited, then this eventually gets freed back in epsilon closure. So I thought that would get called and that would be fine. Or more likely, I think, is if it's this one, in which case the NFA nodes gets another thing added to it. Maybe some resizing happens. In fact, it seems like it does. A new hash set gets mallocked. The NFA node's double pointer points to that new hash set eventually via a double thing. And then because the hash set gets added there, epsilon closure DFS has that set. This double pointer gets brought back whenever we use it. Am I losing it? Well, I return res here, which should be the eventual set that gets created, right? God, I'm so confused. I'm worried that like it's another issue where like res maybe isn't pointing to the right thing and then something happened. Like I tried to do the double pointer thing here so that when you add to res it's going to update correctly, but I'm not sure. And surely if it wasn't being updated correctly, surely like the actual output would be wrong. But it seems to be correct. I drew it out and stuff. DFA init. Oh, I want to get the matching done today. I don't think that's going to happen now. Zobrist add, Zobrist set HS node. Quite get rid of these comments to be fair. Yeah, so when I free, oh, hang on. When I call this function epsilon closure because of the move, okay, so yeah, it is a move. So it's over here. You get the new nodes. You know, if it's empty, I free it straight away. That was the thing I forgot before, but I do that now. Get rid of this comment. Otherwise, if Zobrist didn't exist, then the node takes in new nodes as a set. Yeah. Takes in the DFA for some reason. Oh yeah, so I can get the ID. Checks if it's finishing and adds it to the Zobrist set. And then we create a DFA node using this new node and the particular character we care about. And we append the edge to the current node from the queue to its edges. So yeah, like that hash set, new nodes, should, in my mind, should whoa, what did I just do? So you gotta move, you create this hash set that I call res for result. I initialize it, so this is a pointer on the stack and it's pointing to something on the heap. This hash set with all its fancy stuff. I get the iterable, which I do free at the end. I get the iterable, iterate through it, and I get the current node and I look for edges. And so I'm giving the address of the pointer, not the pointer. I'm giving the address of the pointer, which means when I dereference that address, I'm going to get back this pointer. So the copy I'm giving is a copy of an address, where when I dereference, I'm going to get back this guy. So we're giving copies of the address around the block. So like everyone's getting a copy of the address of this pointer. So when we dereference, we're always hitting this object again. We're always hitting this object. So yeah, when we add and stuff, when we add and when we resize, we should be new malloc, blah 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 blah, fine. And then at the end of it, when we dereference, when we run this, dereferencing this should point to the new address. Dereferencing the double pointer gives us the pointer to the hash set, and we reassign its value to be this one, to this address, so that the HS is pointing to the new set. I'm trying to figure out if like somehow there are new, like the HS news that are being used, but they're not being freed because they're like intermediate, like one resize creates them and then another resize destroys them, but like I thought they would be that would be handled here. So I'm very confused. It really does seem like it's just the malloc of, like it's just that malloc, HS new being. Anyway, I return this res, which is the pointer that will eventually point to the correct hash set. It's a pointer that points to the correct hash set. And then I try to take that move and I call it new nodes because that's the set of new nodes. If it's empty, I free it straight away. And I move on. If it's null, then if it doesn't exist in here, then create the DFA node. Create the DFA node. Okay, I have an idea of what could be happening, but I'm not sure if it makes any sense. When I create a DFA node, I provide the hash set that was created by that function, the move function. I provide that, and that's the correct, that's a copy of a pointer, right? I think, no I don't. What do I think? I'm giving the hash set, I'm giving the DFA, I'm giving the terminal, and I'm giving the Zobrist set. When I run Zobrist add this hash set, I think I need to give a double pointer again. Not because it's resizing. This time it's not about resizing. I think what might be happening is, well, it has something to do with resizing. When you add the hash set, no, I don't believe it anymore. Sorry. I was gonna say, when you add this hash set, what might be happening is, because you're no longer freeing, like in the Zobrist free, you're not necessarily freeing those items anymore. what I thought might be happening is the Zobrist hash table is holding stale versions of sets, like stale sets. Stale meaning, that set has since been resized. But then I disagree with myself because hash sets won't get resized. Like these hash sets that are being added to the servers won't get resized ever again because they don't get edited after they are created. So I don't think that could be the reason. So I don't think that's it. As much as that kind of makes sense, where it's like, I have a Zobrist set, it takes in a copy of a particular pointer, so another version of the pointer that points towards the same address. If if the original version of this hash set changed its value, the new version in here I don't think would, kind of thing, which I think would be a little bit scary. But I don't think that's what's causing this problem, because I don't think it can, because there's no resizing, so there's no like change in the addresses, Yeah, I don't know. It's somewhere. I'm holding DFA nodes somewhere in a structure that. Well, sorry, I'm holding hash sets in a structure that I'm not freeing from. It really feels like it should be the Zobrist, but I'm not really sure. Is this like the same thing over and over again, like the same issue? And then this is new. Doesn't look very new. DFA constructor, epsilon closure, epsilon closure. Oh, it's not a move. Oh, it is a move. We're like 1, 2, 3, 4, 5 DFS calls in, traversing through a graph. This guy as well. Wait, what? Oh, whoa. Wait, what? Did I just never free these? Wait, how has that never been triggered before? Hash set get equals. Hash set equal. Did I just forget to free this? Free. Okay, small wins. I think that seems like could be the reason for that, at least. That very minor memory leak compared to all the others. Does it say anything about hash sets equal? Okay, I think that's not gonna be there anymore. Okay, there's just 1,000 other things to worry about instead. Yeah, it's just so much resizing problems. Maybe maybe it is more of a hassle because the reason why I use all this double point and stuff was so that I didn't have to do reassignments, but maybe reassignments would actually be easier at this point because like you're always keeping track of the most recently created thing, and you're freeing up the old guys, and maybe nothing bad can happen if you do it like that. I mean, I think that did reduce. It was like 111 before, right? So I think that is good. I can't believe I forgot that. That's kind of sad because I knew that every time I create an iterable, I should be freeing it at some point. Guess I forgot. God. Hash set add. When I want to add to hash set, I need to resize it. Do I really need to use the full-on debugger? Like, because the thing is, like, I would have expected something to go wrong, like, properly go wrong. Like if I use a sanitizer. Oops. But there's no real problems. Well, I mean, sorry, there are real problems, but it's so quiet. Yeah, like the sanitizers, the other sanitizers don't really have problems. It's just... What? Oh, right, I forgot that. What did I just compile it? Okay. Leaks. Sorry. Can I just check something? When I do Zobrist free, that's the wrong thing. When I do Zobrist free, if I was to set this to true, I'm just curious what would happen. Okay, so yeah, fairly confident that's not the issue anyway. And I'm also pretty sure that if I was to compile, this with the sanitizer, I'm pretty sure it would blow up in my face. Yeah, okay. So false is the way. I guess I'll have to go through it with the debugger and figure it out, because I don't think it's going to be very obvious without seeing the values properly. Nothing else is really readable. Somewhere in when you resize, this guy gets mallocked. Epsilon close, it's this line. I foolishly thought I could get this done today. That was a lie, wasn't it? When do you not get freed, my friend? When? Which time in the hash set did you not get freed? Like, the old one gets freed. The old hash set gets freed. And the new hash set, which we malloc, becomes, that address gets saved in that double pointer instance. Hash set resize. So then when you resize this double pointer, which was pointing to the old hash, the old pointer or something, is now pointing to the new pointer, which then points to the new heap stuff, right? And then we, do all our adding and stuff, and then we return back to here. So like over here, I think, where NFA nodes, which was a double pointer, was pointing to the pointer, which points to the hash set. So when we put it through there and put it through resize, resize takes that double pointer, dereferences it, takes a copy of the double pointer, a different copy, but dereferences it to go back to the same address and makes its value point to the new hash set. So it's like, you should be pointing to the new hash set. When I dereference you, that address should be pointing to the new hash set. Epsilon closure, if string compare, and just to clarify, this happens on the big input but not the small one, because I guess the small one there was no resizing. Yeah, so it has to, it has to be something where I've lost a resized array somewhere, or I've lost a resized hash set somewhere. I just don't know where it went. What didn't I keep track of? Like, for a big enough input, I don't think adding more A's is gonna. You need ors if you want more nodes and stars, like that. Then you get a resize, and when you get a resize, wait, what? Hash set in it. Another hash set that's not being freed correctly, apparently. That's pretty cool. Call the move function. Then you call init. So that's where the malloc comes from, and apparently we never free it. You have a set of NFA nodes. You create a new set that you call res, and you return it eventually. You return it back to here. If it's empty, you do free it. DFA node star equals null. If Zobrist exists not, then you should create the full-on DFA node. check if it's a finalized, add it to the Zobra set. That is, add the new nodes hash set to the Zobra set. And that's why I think I am keeping track of all of these malloc hash sets. But apparently I'm not. In move I create a hash set for, you know, these DFA nodes, and I store that hash set in here. It's here. I found it. Okay, because I no longer have any need for that. It's the exact same thing as before. I don't need this anymore. What? What? Why didn't it do the thing? Is that good? What just happened? What did I compile with? I compiled with .g, right? Why is it not doing the thing anymore? Could not tag MSL related memory as no footprints. So these pages will include... This isn't even correct. What is happening? I'm pretty sure this is why, by the way. Like, it makes perfect... Like, it all clicks now, because, like, it's a node that you've created. You would have done some at some point you would have done some resizing, but you would have had the node before. So you didn't create the DFA node, so this hash set that you created, it already exists somewhere, so you didn't need to use it ever again. But you had to free it, I forgot to. It's like literally. Anyway. But why is it not doing the thing? What happened to, like, saying 0 out of 0 or whatever? 0 leaks out of 0 or whatever? Like, why is it not saying all that? Or anything? Why is it not doing the thing? And why is it outputting random stuff now? Like, this is my input. Why do you... Compile... Okay. So that's without any of the things. Serious? I finally think I found it and you do this to me? You're joking. Edge from 0 to 1. Like, 0 is not even the... 0 shouldn't even be the starting node. Like, what? Can I just try... Oh no. I've like fully I've obliterated it. I added one line and you're telling me that blew it up? Oh wait, I know why. Ha. I think I know why, at least. I did it the wrong way around. There you go. That scared me. Alright, let me try this leaks again. There we go. Okay. Now I've looked. Oh, my eyeballs. Okay, yeah. I have to correct myself. I need new nodes here, so I can't free it straight away. I had it like this before. Like a goose. But now it makes sense. Okay, now it really makes sense. Oh my god. It's still saying that footprint stuff, right? It must have just blown up. It must have, yeah, it must have seg faulted, and it's interesting that it went to 0, because you can see here, like if I print out, oh, it is 0. Sorry, because the way the numbering works with DFA is different for NFA. NFA, it's like a recursive inductive idea, so it, yeah, sorry, I am dumb. All right, we're fine. Okay, so I think this is fine, and I'm going to stop caring about, okay, I've done those two, and of course there are 2 other things, but I don't care about that right now. What I do care about is structuring this correctly. So let's make our include and our source. Include should have dfa.h, and it should have all our stuff. I'm gonna do, okay, something I realized is I don't need to give the definitions of the structs in the, like I don't have to publicize that at all. Because out of, not habit, but like out of, oh, you're joking. What? Is this like a C++ thing? A value of void star cannot be assigned. Where are you getting that from? Like what? Do I ever use void star? Wait, what? Alright, well, I'm gonna assume that's a... Things, I've used this before. I've literally done like very similar things in NFA.h. Like, it's like almost identical lines. Why is it mad? Ah, it's probably because of this. No, edges. Yeah, it has to have something. It must be something to do with this, right? Wait, let me give the definitions. I literally said I wouldn't do this, but let me give the definitions of the structs, and let me just see if that fixes anything. What? I have DFAs. I've typed defs to replace the name, like to alias the names of each struct. Then I have, and then I have the declare dynamic array thing. Edge, edges, NFA node. Okay, whatever. I'll just leave it. Semicolons? Did I miss? I don't think so. Alright, I'm just gonna delete those for now, because again, I want to try to avoid putting the definitions of the structs if I can. Get NFA lookup DFS. I think that's private, right? The only thing you should have to do publicly is construct the DFA. Yeah. And free it. Construct the DFA. Maybe print the DFA. Oops. And then free the DFA. And yeah, just to clarify, this should be called DFA print. And this should be called DFA print DFS. Okay, so we have construct it, print it, and we have free it. I've lost everything. There we go. I might have a few source files for this actually. Okay. I'm very confused as to why this is crying. Value of type void star. Like, where did the void star come from? Cannot be assigned to an entity of type DFA node double star. Do I have double star somewhere? It would be like type star data and then yeah, because like, let me think about this. DFA edges is meant to be holding DFA edge pointers. So in that case, this thing is a DFA double star pointer. DFA edge double star pointer. So that's probably where that's come from. DFA edge double star, because type is DFA edge star, so it's DFA edge star star is the data thing, which means but when do I ever assign value? Like, when do I ever assign void? The functions are void functions, not all of them, that one is, but like the returns of voids, where's the void star come from? Before I forget as well, I'll just do the if and def. This is really annoying me. We'll say DFA construct. We'll do that, and then we'll say once again, this should be DFA construct, and I should include. Oops, I should include the DFA.h. I need the structs. If I just say DFA edge, will this work? No. Worth a shot. See our struct definitions. Ah, but then I can't. But then other parts of the file can't access. Like, other files can't access these definitions, right? So maybe it has to be one file. I don't know if that makes any sense, but let me just try this. So get NFA lookup, get NFA lookup. So we have the ability to get the lookup, which the construct function relies on. We also need to be able to run epsilon closure, get epsilon closure, which I've heavily documented because I'm very paranoid that I'm going to forget why things are the way they are. Move create a DFA node, create a DFA edge, DFA edge. DFA init as well. So these like creational things. DFA construct. Free stuff. Print the DFS, free the DFA. Okay. I'll even chuck the to-do list over here. So huh. Alright, which means my compile functions need to yeah, I really do need to get the CMake files done. Oops. Oh no. Fine. Oh wait. Yeah, okay. It's just because I renamed some stuff. That looked kind of weird. paths, I compiled it wrong. Alright. Structure is a bit better, although to be fair, the source code is kind of ugly looking at the moment because it's all just slapped in one place. I would have thought I'd be able to, but yeah, because the struct definitions are privatized, so whichever file has them has access to the structs thingies. But maybe, yeah, like see, this relies on source edges, so it relies on that. I feel like all the functions will need that, right? Source edges on. In fact, I do rely on the previous packages and their structs as well. I could make getter. I can make getters, I guess, but that's annoying. So you know what? Screw it. I'm just gonna chuck it all in here. I forget where this goes. Yeah. All right. So I think we're good. Yeah, we'll stop there. We'll stop there. And then tomorrow, hopefully, we'll have like the matching stuff sort of going. That'll be good.